Hello, and thanks for joining this Ignite 2020 session on Windows Updates and Recovery. I'm Steve Dicitis, a program manager in the Azure Edge and Platform team. In this session, I'll cover the latest set of capabilities we've introduced in Windows 10 version 2004 to make the Windows Update and recovery experiences smooth and seamless for you as IT pros and for your users. These capabilities are based on feedback many of you have shared with us. Over the last few releases, and as we plan for future releases, our team is looking to bring to commercial users the same set of improvements we're bringing to home users. This includes improvements in the update platform, as well as improvements in the update experience. By platform, I mean the infrastructure Windows uses to scan, download, and install updates. By experience, I mean what the end user will see, everything from learning an update is available to the install experience. Next, I'll share guidance on how to manage features on demand and language resources during and after a Windows feature update. This includes reviewing what options you have today and a deeper look and demo of one approach using Windows Setup custom actions. Let's get started by looking at changes in the update platform. As a quick refresher, let's look at the content needed to perform Windows 10 feature and quality updates. The core OS content includes the base media setup files and the core OS image. Next, we have regular updates to this media, including the latest cumulative update or LCU, servicing stack updates or SSU, updates to the setup files themselves, and updates to the Windows recovery environment. In addition, there are other optional components, including features on demand, language resources, and OEM-provided driver updates. Before I forget, check out the Ignite 2020 deployment session entitled What's Changed and What You Need to Know About On-Premises Windows Update Management. This session will describe work we're doing now to combine the LCU and SSU into a single package to make deployment easier. As you can see, where this content is acquired from varies based on the workflow. For media updates, content comes from several sources, including the Volume Licensing Servicing Center, Dynamic Update, the Microsoft Update Catalog, and from OEMs. With today's servicing flow via WSUS, the content comes from similar sources. Servicing via the Unified Update Platform, or UUP for short, is a much simpler story. Today, with Windows Update for Business, the content comes from Windows Update. In the future, when UUP on-prem ships, the content will come from WSUS. You can think of UUP as one-stop shop for Windows 10 update content. For more information on Windows Update for Business, check out the Ignite 2020 deployment session entitled Optimized Monthly Windows Update Delivery for Remote Work and Business Continuity, and see the demo, how to use the Windows Update for Business deployment service to enable cloud-driven monthly servicing while remaining on a specific version of Windows. For home users connected to Windows Update and for commercial users connected to Windows Update for Business, UUP is enabled by default for all use cases, including migrating and acquiring optional content. It is the most complete delivery of UUP content. UUP on-prem will provide IT pros the ability to use WSUS and Config Manager to approve and host update content on premises for the critical use cases including feature updates, quality updates, optional content migration and acquisition. UUP on-prem was in private preview. However, we hit a design issue that caused us to adjust the implementation. We are looking to resume the private preview as soon as we can finish coding and testing this adjustment. Lastly, contrast UUP-based updates to media-based updates. Optional content, for example, is not on the media. Language FOD resources ship via separate media. Dynamic Update, however, is enabled by default and will acquire content from Windows Update. Speaking of Dynamic Update, with 2004, we've added support for delivery optimization of DU content and will be backporting to 1903 and 1909. We've also included additional dynamic update options to control which subset of content to acquire. Let's move on to the 2004 improvements that tie into the update experience. Minimizing user disruption has been an area we've been focused on for several releases. As you can see, we've made significant improvements to reduce feature update offline time. With 2004, we have a slight reduction down to 22 minutes at the 50th percentile, while early numbers for our next release are looking good at 13 minutes. I've included a testimonial from an IT pro I work with. He is seeing, quote, huge reduction in offline time as his organization moves to the 1909 release and moves from task sequences to the pre-UUP servicing model. The 1909 feature update offline time is very low, about 5 minutes for those users coming from 1903, and we expect the same for the 20H2 release. We've also added new setup parameters to control when feature update offline time begins. Our recommendation is to separate the feature update into 2 phases. First, call skip finalize so the feature update can run silently in the background without interrupting the user. This will also ensure that if the user restarts the PC, the restart will not force the update. Then you can call the finalize step so you can reboot and commit the update. This allows you to set a maintenance window just for this last phase instead of the 2 or more hours you may be using today. Also new in 2004 are commands to help manage reserved storage. These commands are available via the DISM command line tool, DISM PowerShell commandlets, and the DISM C API. With these commands, reserve storage can be used on devices that did not ship with 1903 or later. Once reserve storage is enabled or disabled via these commands, the state is preserved across the OS update. See my blog, Managing Reserve Storage in Windows 10 Environments, for more details. Starting in 1803, we've added the capability to allow IT professionals to customize a feature update by running their own custom scripts during and after a feature update. We call this custom actions. With 2004, we've extended custom actions to support executing scripts after a user uninstalls a feature update and after a successful feature update. Later in this session, I'll show a demo showing how custom actions can be used to migrate FODs and language resources for pre-UUP feature updates. Let's switch gears and talk about device health. Specifically, when you install a feature update, we want to be sure you have the necessary capabilities to get devices healthy if the unexpected happens. In the rare event that a feature update fails, we have the capability to bring you back to a good state on the Windows 10 version you started from. We call this rollback, and it is automatic. We continue to work to reduce the reasons for rollback. As you see from the graph, we brought this down to about 1.4% in Windows 10 version 2004. I know many of you are already familiar with Setup Diag. Setup Diag is a standalone diagnostic tool that can be used to obtain details about why a Windows 10 update was unsuccessful. With the release of Windows 10 version 2004, Setup Diag is included with Windows Setup. If there is an issue with the update, Setup Diag will automatically run to determine the cause of the failure. Please see the documentation for more details on how it is integrated and where the output is logged. We are also working to integrate Setup Diag output directly into Config Manager, showing the top setup errors by device counts and easily allowing you to drill in to see individual devices that are impacted. Also new in 2004 is a capability we call Cloud Recovery. With Cloud Recovery, we now support downloading OS content from Windows Update to recover devices where the on-device system files have severe corruption. This new capability complements the existing on-device recovery capability, which is an imageless reinstall of Windows leveraging the existing OS files. Both recovery capabilities support the option to keep one's files or to remove everything. Now that we've taken a brief look at some of the new update and recovery capabilities in 2004, let's look at a demo of migrating FODs and languages using custom actions. To help frame the problem, recall the slide I presented earlier. One of the top challenges I hear from commercial customers is how to preserve languages and features on demand during an in-place feature update. Let's take a look at some of the options available. The first option is to adopt UUP via Windows Update for Business. These devices will automatically preserve FODs and language resources during an update. This is device specific. Devices get only the content they need, but of course the content is acquired from Windows Update. The second option is to enable dynamic update. Dynamic update is the acquisition of update content that is not on the installation media. This makes it easier for setup to complete as it has the latest servicing stack updates, for example. It also ensures FODs and language resources are successfully migrated. This is an option for both media-based feature updates and pre-UUP WSUS-based feature updates. Like option 1, devices get only what they need, but will acquire via Windows Update instead of an on-prem source. The third option is to customize the Windows image before deployment. For example, adding additional FODs and language resources into a mounted offline Windows image, then using this image for the in-place update. This works well if all devices have the same content needs, and thus the same image can be used for everyone, but it requires some scripting to perform the customization. I have a blog that covers this in detail entitled Updating Windows 10 Media with Dynamic Update Packages. The fourth option is a partial solution. This approach uses the Windows 10 setup option /install langpack to add language packs and language capabilities, such as text-to-speech, from a folder that contains the packages. This approach lets an IT pro take a subset of optional content and stage them within their network. The fifth option is to add optional content after the new OS is deployed. IT pros can extend the behavior of Windows setup by running their own custom scripts during and after a feature update. Let's take a look at the scripts to make this happen. There are 3 scripts I'll walk you through. The first script is to create a FOD and language pack repository for only those FODs and languages I'm interested in. This repository will be used as the source to install optional content after the in-place update has completed. This script will run once on a back office machine, not on the Windows 10 device that is being updated. The second script will run on the device before installation begins. It will save the state of languages and features on demand that are installed. It will also copy a subset of the repository locally to use for installation. This will reduce the network traffic to the device. The third script will retrieve the state from the source OS and install missing languages and FODs. Lastly, it will install the monthly update and restart if needed. Let's take a look at the code for creating the FOD and language pack repository. I start by declaring the location of the FOD ISO and the language pack ISO. I then mount the Windows OS image from our setup/sources folder. I'll use this mounted image shortly to perform an export. Next, I mount the FOD and language pack images and capture the drive letters for each. Then I use the DISM export source command to export only those FODs that I'm interested in, exporting them to the target folder. Note that in this code, I'm only showing 4 capabilities. The blog has full code and all capabilities, making it easy to comment out those that you don't need. Next, I copy all language packs to the root of the repository. This lets me have a single repository folder that I can host within my network instead of one for FODs and one for languages. Now, let's look at the first script that will run via setup's custom action. It is called pre-install and will be called by setup before OS installation starts. This script will save state from the source OS and use it to determine what new content should be installed in the new OS. I'll save the language installed, the capabilities installed, and the OS version. Also note that my repository path is a network location, in this case, z:/repo. The islang file function is simple. Given a path, it'll return true if it contains one of the 2-character language codes such as EN, DE, or FR. I'll use this function later when copying from the optional content repository to a local repository. To get started, I save the installed languages using dism get international command. From the output, I can save all languages and capture the default system UI language, or system language for short. After saving these languages, I use get Windows package to save in my log file the installed packages. This is useful for debugging. Then use get Windows capability. I'll save all installed capabilities. The next step is to create a local repository of FODs and languages. To do this, I start by looping through the files that are part of the remote repository that I created earlier and stored on the network share. Remember the islang file function? I use it here to check each file, and if it is a language-specific file, I copy it locally, only if it matches a language in use by the source OS. This step significantly reduces the number of files that I'll copy locally. Otherwise, if the file is language neutral, I'll copy it. Now, let's look at the second script that will run via setup's custom actions. It's called post install and will be called by setup after setup completes successfully. Like the first script, I'll declare some variables for storing the source OS state that I saved earlier. Also note I'm declaring the path of the monthly update that I'll apply at the very end. After a few basic checks, I retrieve the languages that were used in the source OS. Then I'll loop through these languages and install the language pack for each. I'll skip the system language as this will match the source OS and thus already be installed. Next, I retrieve the source OS capabilities that I saved earlier and save the capabilities that are currently installed in the new OS. For each capability installed on the source, I'll check to see if it's installed on the new OS, and if not, I'll add it via add Windows capability using my local repository folder as the source location. Next, now that I've updated the new OS with FODs and languages, I'll install the latest monthly update. Why am I doing this? This is necessary to ensure that quality and security updates to the RTM, FODs, and languages are applied. Finally, I'll restart the device if I have pending updates due to installing the latest monthly update. Note that I use start process to schedule the restart in 10 seconds, giving the main setup process time to exit cleanly.
Let's see Windows Setup Custom Actions in action. I'm starting on Windows 10 version 1809. Let's confirm via Settings. Next, let's see what languages I have installed. As you can see, my system language is ENUS, and I have German installed as a second language. Next, let's look at optional features installed. I have some supplemental fonts installed, the German language experience FODs, the routing information protocol listener, along with some remote server administration tools and XPS Viewer. To integrate my scripts with setup, I've created a folder under System32 Update Run with a folder that is named from a recently created GUID. The pre-install command file will launch my pre-install PowerShell script. And similarly, the success.command file will launch my post-install PowerShell script. Both of these scripts are in my C:temp working folder, along with the LCU I'll be installing and the Windows 10 version 2004 setup media. Before I launch setup, let's look at how I have updates configured. You'll see I have set up this device to point to a WSUS server, although in this case it actually doesn't exist. Okay, let's launch setup. Note that I'm disabling dynamic update as I want to showcase installing languages and FODs via an on-prem location. Setup is now running, and before installation, performing initial checks including disk space requirements. Now you can see our pre-install command script executing. This is before installation starts. Now that the script completed, installation will start. Note that I ran setup without using skip finalize nor finalize option. I wanted to run it interactively to better show when the pre-install script ran and when installation started. Typically, this installation would be happening quietly in the background. Now that we've rebooted, this is when offline time begins. Although we continue to work to reduce this time, it is not this fast. I did speed up my demo video. At 100%, we are executing the post-install script, adding any missing optional content and languages, as well as the LCU. And of course, a final reboot given we installed the LCU. Okay, we should now be in the new OS. Let's take a look in settings again. We are now on Windows 10 version 2004. Let's check out languages. As expected, we see English, but we also see German along with the German language experience VODs. That's a good sign. Let's see if optional features migrated. I see supplemental fonts, the routing information protocol listener, RSAT tools, and XPS viewer. It is easy to see these via the date installed. Let's take a look at the log file that these scripts wrote to. I see the pre-install script captured the install languages, English and German. I also see the packages and capabilities that are installed, including the German language experience VODs. And I see the listener, RSAT tools, and XPS viewer are installed. Next, I see the local repository being created, the files copied from the remote repository. Looking at Notepad, only the English and German files were copied. That's also good. Now we see the output of the post-install script. I see German was installed, along with the German language experience VODs. Lastly, I see the packages installed and pending after the LCU is installed. Notice the pending state of the roll-up fix. This is the newly installed LCU prior to the final reboot.
If you haven't already, check out the new capabilities we've introduced with 2004, including cloud recovery, controls for storage reserve, controls for managing feature update offline time, and dynamic update improvements. Remember, UUP is one-stop shopping for update content and will be integrated with WSUS soon. Until then, there are multiple ways to handle optional content migration, including extending Windows setup via custom actions. Have any questions? Contact me at stevedia@microsoft.com. And as always, thanks for watching.